Your Academic Skills Center presents this video series to help you strengthen your statistics skills.
Hello STAT students, and welcome to the Introduction to Quantitative Reasoning and Analysis. My name is Janine Allwright, and I'm the Instructional Specialist at Walden's Academic Skills Center, where I lead the Statistics Tutoring team. In this video presentation, I will explain the basic statistical concepts to get you started with quantitative reasoning and analysis. We will start with an explanation of the statistical model equation and illustrate this equation with a fun example. This model equation can be applied to any quantitative research article, and I'll share library tips with you to make the search for an article easier. We will also open SPSS, and I will introduce you to 3 specific SPSS data sets. We'll talk about the unit of analysis and levels of measurement for variables. And lastly, I will conclude this presentation with an explanation of Walden's definition of social change that can guide you in the requirement to interpret statistical results in light of social change. Let's get started. Now, what you see here on the screen is a mathematical equation, y equals fx plus e. Now, this is probably not the first time that you've seen this equation because we use that same equation in math, and I'm pretty sure that you were introduced to this early on, either in high school or college. Now, some of you will remember this as y equals mx plus b. I learned math in Europe, and for me that was y equals ax plus b. It all depends what part of the world you're from. But basically, on the left side is the outcome variable, the y. We call that a dependent variable in statistics. And on the right side, you'll find the x. Now, that does not necessarily need to be just one independent variable. It can be multiple, and it often is. The f stands for function, like we're going to do something to these x's. And then we have a leftover element here, the e. We call that the error, but not an error in the sense of it's a mistake, but it's just that part of y that is not explained by the x's. Now let's talk about an example here that might illustrate this for you with a bit more detail and fun. Let's bake bread. Let's imagine that we want to make a bread, right, in the oven, and for that we need ingredients. I'm not much of a bread baker myself. I shine in different ways with cooking, but I know that we need flour to make bread. Some people put butter in it, milk, yeast, water, seeds. There are all kinds of elements that one can imagine that you can put in bread. Some people put raisins in there and what have you. Those ingredients together are the x's. Those are the independent variables that we are going to transform, right? Remember the f function there, that is the transformation process. So we are going to measure our flour and all our ingredients. We're probably going to sift some of those items together. We're going to mix, we're going to knead, and then we're going to put it in the oven and we're going to bake. And hopefully that will result in the y, the outcome, because that's our dependent variable. We're hoping that we will get a beautiful bread out of the oven. Now, I don't know what your life is like or where you live, but I live in Colorado on high altitude, and that always influences what you bake. So I would have to adjust my recipe for that, or otherwise it will influence the quality of the bread when it's done. You can also imagine that if you have children, and I am in that same situation, who get, very curious, my daughter will walk up to the oven, mid-bake, can open it, and that will actually influence the result. I've also shared with you already that baking is not my deal, right? So lack of talent also influences how that bread comes out. And that is that E factor. It's not exactly an error, right? I mentioned that earlier, but it will certainly influence how that bread comes out. To summarize, all my ingredients were all the independent variables. I transformed this with the process of mixing and kneading and sifting and baking and adding all these ingredients that I want in my bread. And then I bake my bread and the bread comes out, but it's also influenced, the outcome is also influenced by elements that I do not have control over, but that will influence the result. And that is what this sentence is about, that the statistician G. Box summarized here. All models are wrong, some models are useful. In that sense, the error part tells us that all models have an element that we cannot control, but we can still predict a dependent variable based on the independent variables and whatever we do to these variables. So that's a good starting point here. I'll give one more example here. Imagine that we want to measure our income of participants, and we measure that by how many hours these participants work, because we know what their hourly rate is, right? So if I know the hourly rate and I multiply that by hours worked, I get my income for that participant, but I cannot control for where else participants might receive money. Maybe people have investment income or have rentals that generate income, or somebody in the family might be giving them money. That is the error factor here. You see, it's not an error in the sense of it's a mistake, it's just parts that we cannot explain. Now you are asked to engage with the Walden Library to find a quantitative research article and then apply this equation to that research article. In essence, find the independent variables, find the dependent variables, and then you think about and hypothesize about what parts of this relationship does not explain the dependent variable, the outcome variable. And to that end, I'm going to take you to the library here. Let me bring that up real quick. I've set that up. So when you go and look for an article in the library, this is the landing page in the library, and I'm already in a database here that comes up. I like using the advanced search that you see here. When I click on that, that will activate. And here's my library search. And my field is refugees. That's where I completed my dissertation in refugee policy in the United States and Canada. And some of you know I'm a Walden graduate, and I've completed my dissertation already. So let's look for, instead of refugee policy, let's look for refugee management. That would be in my field. And I can add quantitative to this title, and that will give me only quantitative research articles. I recommend that you search only for quantitative because you don't want accidentally to use a qualitative research articles, because that doesn't have variables in the same way and it has nothing to do with statistics. Now I like to search for peer-reviewed only, make sure that it's scholarly, and we can set the year for the last 5 years, and it looks like that has already been set here from 2016 to 2021. If that comes up differently for you, then you can use the slider and shrink that time bracket. And here you can see that I have some quantitative research articles that came up, and it would be interesting to just click on one and then see if it fits with your interest. To that end, I do want to mention that it helps to look in your field and search within that subject of interest. Any engagement with the library is something that you can really take advantage of, right? And some of you have come in with a dissertation subject, but some of you have not. So every time you go to the library, make sure that you use that experience to the fullest and look for your subject of interest that will expose you to journals in your field. It will give you articles that are good for you to read because they will broaden your knowledge base, and they might narrow down what you could research for your dissertation subject. But also, I think it is much easier to write an article critique or, a paper about a subject that truly interests you. Now I'd like to take you to SPSS to take a look at the program, discuss the different viewpoints, and show you 3 data sets that you'll be working with. The name of the data sets are General Social Survey 2014, GSS is the abbreviation, the Afrobarometer, and the High School Longitudinal Data Set. These are 3 real data sets which will allow you to bring interesting social change interpretations. Now, the General Social Survey data set is an American data set that takes the social temperature of our country. I think it's updated once a year, so they truly go out into the field and collect data by asking participants to complete surveys. The Afrobarometer, the word or the name already says it, it's an African data set that takes the democratic temperature of the African continent. And the high school longitudinal data set, that's a special kind of data set. The word longitudinal implies that this is measured over more than one time. This is actually a data set where they returned and they measured students at one level in high school, and they came back multiple years and measured the same students again. Or alternatively, they might have measured different groups, but just to get an idea how high school students are doing. So let's move to SPSS, and I have that set up here. And we're landing here on that last data set. This is the high school longitudinal data set. When I open a data set, I always make the label column a little wider. Now, if you've listened to the earlier presentation, the Ease into Statistics presentation, you heard me talk about downloading the data sets early for yourself and save them on your computer. Every time you click on these data sets in the classroom, you're actually saving them in your download folder. So you should have all these data sets after you click on them once. You don't have to keep clicking on these data sets. They're rather large, and you don't want to take up all that room on your computer, and you don't want to have these multiple versions of the data set. So this is the high school longitudinal data set. You see all the variables here relate to students and their level of education here, how they're doing in science, in math, how their teachers are doing, and you can recognize the T1s and the T2s here. And that is what I meant. There are T1s and T2s, and you actually have T3s as well on your data sets. I want to mention that the data sets that I'm showing you are not the same as the data sets that you use for your work. Those are just, I have a larger version of the data set. Your data set is split up, is a sliver, if you will, and it has a letter at the end of the title, like an A, B, C, D, or E. To that end, the results that I get with the data sets that I will show you in this video and coming videos will never be the same as what you will generate on your end when you work with your data sets. Here is the General Social Survey, abbreviated with GSS 2014. I will make that label a little bigger as well. And you can see here, those are all social variables, if you will. Variable names here in the name column are arbitrary names that the researcher assigns. They cannot be more than 8 characters, or researchers can work with underscores here. This has little value to us though, because the real information about a variable is the label. And I recommend that when you write, that you actually use the label in your writing, as the name is just not clear to anybody. Now let's look at the Afrobarometer. Again, I'll make the label column a little bit wider so we can read the label well. And you can see here that these variables relate very much to how the African participants feel about their country and how they're faring democratically, what their lives are like, how they feel about democracy in other countries, what they think about that, what their level of poverty is, and so on. Now, I want to mention, when we land on a data set, it opens itself here in the variable view, as it notes here at the bottom of the screen. And that's where the variables live. But we can also click on the data view, and this brings up the actual participants. The variables have now moved to the top of the columns. And if you keep your mouse, move your mouse slowly and hold it on a variable name, the variable name and its characteristics will reveal itself. And you can see here, for instance, country by region. I see all kinds of numbers here. There are 4 regions in Africa that are assigned, number 1, 2, 3, 4, and I'll show you the details of that later. But the variables on top here leaves room for all these rows. Every row is a participant. I have many participants in this data set. You will not have that many, but I can keep scrolling down here. Do you see that? I can actually pull this down, and I literally have thousands of participants in Africa. It's a really big data set. At least my version is. Yours will be smaller. So you can see I have all these participants, and I know a whole lot about these participants. I know that this participant, for instance, lives in country 34, whatever that means, how that is defined. The region is number 3. The urban area here is 2. This participant lives in a household with 6 adults. The age of this participant is 24, and so on. So you know a whole lot about this participant and every other participant, really, because I can move my slider at the bottom to the right, and I can see that there are many more variables here. For the most part, you will not really be working in the data view, but if needed, I will let you know to open up the data view. But we actually look at this in the variable view. There's one element I want to mention here. The variable view is where your variables live, right? The data view is where your participants live, but it also shows you what the unit of analysis is. And that is something that you really want to familiarize yourself with. And I'm going to move back to the PowerPoint just for 1 second. A unit of analysis is that what is being studied in a research study, what is being analyzed there, what are the data sets about? Are we dealing with individuals? And if yes, what kind of individuals, right? Are we dealing with groups? Could it be geographic units, social interactions? You can imagine that data sets can have different kinds of insight. Not all data sets have individuals as their main focus of analysis. For instance, for my own dissertation, I researched newspaper articles. So those were the rows for me, if you will. So when I go back to the SPSS here, you can see these rows here in the Afrobarometer data set. The unit of analysis in this data set is the African participant, right? If I move over to the General Social Survey data set, the unit of analysis, let's click on that data view again. Every person here is an American participant who filled out the survey and shared all that information, what their occupational prestige score is, what their socioeconomic index is, their age, and so on. So the unit of analysis for the GSS dataset is the American participant. And of course, for the high school longitudinal dataset, it is the American high school student. I'm going to click on the data view, and now I know that every row here in the data view represents a high school student. I know that student's gender, I know that student's parents' highest level of education and their socioeconomic status. I know how they're doing on math. I know how they're doing on science. So the unit of analysis here is the individual participant that is analyzed in the data sets. And again, in these 3 data sets, the unit of analysis are indeed people, but that doesn't necessarily always have to be the case, right? So that answers the unit of analysis question here. Let me bring up that slide again. Now, the next part of identifying variables, and if you started with the skill builders, that's very well explained in there. When we talk about variables, we want to really separate the qualitative variables from the quantitative variables. And there are 4 different levels of measurement, and it's a progressive movement. Nominal is the lowest measure of level of measurement. Ordinal is the next one. Then we get interval, and then we get ratio. Both nominal and ordinal fit on the categorical side. Those are quantitative variables. They cannot be used as number variables with a mathematical value. Continuous variables include the interval and ratio variables. We call these quantitative variables, and actually SPSS calls these variables scale. Here is a different setup of the distinction between the levels of measurement. You see the categorical ones on the top there and the continuous a little lower, and it organizes itself with nominal, ordinal, interval, ratio. Now, a nominal variable is just that. It's just words such as gender, right? You can be male or female. You can't rank it. It is what it is. They are just 2 groups. Ordinal is also nominal. It's nominal and ordinal. You can rank it. For instance, clothing size, small, medium, large. I can give some kind of order to these 3 sizes. An interval variable is a variable that is equally spaced. For instance, what is the scale of happiness from 0 to 10? I can space these from 0 to 10 with an increment of 1, right? They're equally spaced. But the highest level of measurement is a ratio variable. And a ratio variable is rather rare. You don't see it that often on data sets. You need an absolute 0 point for that, and you cannot have negative values. And it's always easy to find that on SPSS because you could actually look in the data view and recognize if values can go below 0. Because if they do, then it cannot be a ratio variable. I have to put a disclaimer here, though. Different statistical books will interpret the ratio variable, in a different way. So this is the way that I was taught. A ratio variable has that absolute 0 point and no negative numbers. Age is a good example for a ratio variable because we know what 0 means. That's a newborn. We do not have negative ages, right? But every year is exactly 1 year after the last year and exactly 1 year before the next. Now let's go back to SPSS and see if we can bring up these levels of measurement. I'm going to look at the General Social Survey data set, and I'm going to click on the variable view. Here we are. The level of measurement is defined by the researcher here in the measure column. However, I want to encourage you not to necessarily trust that. It's up to you to determine the level of measurement. On some of the data sets, there are tiny mistakes here in the measure column. For instance, I think when you open the GSS, the age is actually set to nominal. I changed that to scale because I know when I click on the values column and I can click on these 3 dots, that's called an ellipsis of that variable, and it will bring up how that variable is defined. And I see here values that are assigned, but I don't see any groups. I don't see any age brackets here. You know, when you fill out a survey, I'm sure that you've seen questions where the answer allows you to pick a bracket, right, between 0 and 20 years, between 20 and 40. This is not that kind of variable. This is a variable that is ratio because it cannot be 0. Sorry, pardon me, it cannot be negative, and we know what 0 means, and it's evenly spaced. Now, the researcher took care of some values here that he assigned for answers that participants don't provide. That's the decay, they don't know, or it's not applicable, or they're excluding people here older than 89. That is what the researcher coded here. That is neither here nor there for us. We don't really have to address that. But the lack of groups shows me that this is a scale variable. And SPSS calls these interval and ratio variables scale. You can see that here. There are only really three measures of measurements here, level of measurements. It's nominal, ordinal, and scale. So scale combines interval and ratio. Now the categorical variables, here's a variable that the researcher has determined as nominal. Let's go look. This asks whether the participants are a citizen of the United States. I can click on the ellipsis here in the values column. Here we go. And I can see groups now. I'm not going to consider the 0 group, right? It's not applicable, but the yes and the no group are important. But the 8 and the 9 are not interesting to me either. They will be excluded from our analysis, but I have 2 groups here. They cannot be ranked. That makes it a nominal variable. And I want to encourage you to click on that values column, because in any stats course, that is rather important to familiarize yourself with how that variable acts in this data set, right? It's important to understand the level of measurement, because in future work, you're going to have to determine whether a variable with its level of measurement fits a specific test. So it's a skill set that you develop over time, and there's nothing like the current time, right? So start practicing with the level of measurement. Now this brings me to the last part of our presentation, the social change aspect. As you know by now, Walden is a social change university. We were founded more than 50 years ago by Rita and Bernie Turner, who introduced us to that concept of social change. This is all about doing good in the world. Let me bring up a definition for you of social change that shows you that this is all about the improvement of human and social conditions. That's what we call positive social change. Now, for any work here at Walden in any course, including stats courses, you will be asked to put your interpretation in the context of social change. Let's talk about that for a moment to understand what that really means. I think that when we interpret statistical variables, when we offer descriptive statistics or talk about inferential test results, it always helps to keep the stakeholders in mind. And what I mean by that is there are 2 aspects of stakeholders that we should remember when we interpret statistical results. Who wants to know about these results, and who benefits from knowing? These are 2 different groups, and I want to illustrate to you what that means with an example from the Afrobarometer data set. Let's go back to SPSS and pick 2 variables there and hypothesize on the stakeholders for these results. I'm going to bring up the Afrobarometer data set again. Here we are. Now I'm going to pick 2 variables. The first variable I want to pick is country by region. This is a nominal variable. I can check that that is actually the case by clicking on the ellipsis here. And indeed, I see 4 groups that are mutually exclusive: West Africa, East Africa, Southern Africa, and North Africa. And I can combine this nominal variable, hypothetically. I'm not running any tests on this yet, but we can combine that variable with, here's a variable, lived poverty index. It tells us how poor people truly are. At least that is the poverty level that they report when they were surveyed for this data set. Now, this is mentioned as a scale variable. You can see here an example of a variable where the researcher chose not to complete the values column. That sometimes happens. And let's go look at that variable with a bit more detail in the data view. As I mentioned before, in the data view, the variables will reveal themselves here at the top of the columns. And I can move this data set to the right and find that lived poverty index, and here it is. The fact that it's called an index probably means that it was calculated, because this is one of those variables that is really hard to project as a participant. How would you know your lived poverty index, right? So it's probably calculated with other values, but I can see that there seems to be an absolute 0, and I don't see any negative values. There must be some kind of scale used here. I don't know exactly what that is. So I'm going to err on the side of caution and just call this scale as SPSS, names continuous variables. That is the choice for interval or ratio variables. Now, when I hypothesize on putting lived poverty index together with those 4 regions in Africa, I could talk about how poor certain regions in Africa are. I could actually compare these 4 regions for poverty. Let's think about the stakeholders. Who would want to know about the poverty in those 4 regions, and who would benefit from knowing? For this African data set, I can imagine that this might be important information to big institutional governmental investors, such as the International Monetary Fund, the World Bank, maybe the World Health Organization. I don't know if you've ever traveled in Africa, but if you have, you probably saw the financial aid, US financial aid signs everywhere. These are big investments that happen in Africa on a regular basis. And these big investors surely want to know how poverty is situated on the continent. Now, let's go back to that definition of social change, and we can see here who wants to know. Those big institutional investors probably want to know, the government investments, and they would want to know where best to allocate that money to when they invest. They want to know how certain regions are doing compared to other regions. Maybe the leaders in Africa want to know how they compare to other parts of Africa. So I've applied that stakeholder method here. I also think that people on the ground benefit from knowing from this kind of research. Ultimately, this will trickle down into positive social change on the ground. And with this last mention of social change, our presentation has come to an end. This completes the introduction to quantitative reasoning and analysis.
Thank you for watching this video presentation. If you have course-level statistics questions, reach out to our stats tutors at statsupport@mayo.waldenu.edu or view our statistics support resources at academicskills.waldenu.edu.